All right, Scholar, here we go. We're looking at direct variation. Direct variation is our first topic in linear functions. And when we talk about direct variation, there's typically some sort of relationship that exists where one variable will directly influence the other. Let me give you an example. Suppose that you are doing an analysis that compares temperature to ice cream sales, right? At the beach or something like that. I don't know, like the Abbott's at the lake, or at the lake, right? At Charlotte. Thank you. I couldn't think of the word Charlotte. So yeah, what do you guys think? If it's 100 degrees out, more ice cream sale, right? If it's 25 degrees out, very little, okay? So there is a direct variation that exists between those things. Would we agree? Okay. And typically we can consider that to be a proportional relationship, right? So one is going to directly influence the other, okay? Now, here's the deal. I have just numbers here to start, right? I'm not really doing anything with respect to an example of ice cream to temperature. So this is just using numbers to start, okay? Guys, if y is 15 and x is 5, how did I get from 15 to 5? I divided by 3. Now, I'm glad that Aiden didn't say subtract 10, because when we talk about variation in proportionality, that's always a multiple or a division of numbers. Do we agree with that? Okay. So if I go from 15 to 5, what did I have to do to go from this number to 9? Well, I had to do some sort of division. And what did I divide 15 by to get 5? 3. So if I take 9 and do the opposite, which is to multiply by 3, what would I get for this value of y? I should get 27. Okay. Now we can just do that pretty easily, right? And one of the ways that we can do that is by actually creating a proportion. So if I want to compare x to y, well, then we're doing 5 to 15, and we're doing 9 to some value of y that we don't know, right? Well, how do we solve proportions? We cross multiply. And so do you guys agree that I could do that right there? So I get 5 times y equals 15 times 9. And if I solve that, I will get 27, no doubt. Now that's a pretty easy one to do because the relationship is easy to see. Do we agree that the relationship on the next one is not as nice, right? How do I go from -6 to 4? How do I go from -6 to 4? Well, I mean, there is some way to multiply to do that, isn't there? Okay, now if we really want to sit here and try to figure it out, we're kind of out of our minds, aren't we? Way better off just setting up the proportion. So x is to y as -6 is to 4 as some value of y is to 9. Okay, guys, do you understand that this first fraction that I have here is just showing where the x and the y goes, right? Just so I don't flip those around and mix that up. So now I'm going to cross multiply. And I get y equals negative, let's see here, 14. So, all right, so here's the deal, guys. Our answer doesn't always have to be what? A nice integer, right? We could get something that is a fraction, and that's what happened here. So this would reduce to be -27 over 2. Cool? All right. And again, last one, x is to y. So when y is 12, x is 16. So what is y when x is 24? All right, cross product. What's 12 times 24? What is it? 288. And does 16 go into 288 evenly? It does? How many times? 18 times. I got a quick question, right? And I want, let's see, who do I want to help me with this? I want, Nick, I want you to help me with this. Nick, suppose I got an answer of 30, okay? It worked out nicely, you get 30. How would you know, Nick, that that answer doesn't make any sense? I want you to think about it for a minute. How would you know that 30 doesn't make any sense? And there's a real simple reason why. Exactly. The comparison here, guys, is that y is smaller than x, right? Which means when I do this comparison, this y better be smaller than that x, right? It's not going to get bigger if they're directly related, right? Okay. Guys, here's another way to think about it, right? No, well, actually, I want to hold off on that. We'll do that in a minute. Forget I just said that. Example number 2. The distance a person can travel varies directly with time if they've been traveling at a constant speed, right? So if I'm driving 55 miles an hour, how far do I travel in 1 hour? 55 miles. How about in 2 hours? 110. How about in 3 hours? 165, right? So again, time, constant speed, direct variation, okay? If Phoenix travels 78 miles in 1.5 hours, that's a comparison, right? Miles to time. And what did Phoenix do? He traveled 78 miles in, oh, guys, one thing. And I'm sorry that I did this. I got to fix this. Miles to hours. Why did I just change that? Well, yeah, I mean, I'm not really worried about that so much because it doesn't really matter because I'm going to wind up solving for whatever when I put the variable on anyways, right? The reason I changed, yeah, go ahead. Exactly, right? Like, what if I said Phoenix travels 78 miles in 1.5 hours at a constant speed, how far will he travel in 35 minutes? So now I got to make sure that I have consistency in the units, don't I? Okay, so paying attention to that's kind of important, right? So I go 78 miles in 1.5 hours. So now the question is, at the same speed, how far will I travel in 2 hours, right? So in 2 hours, how many miles will I travel? All right, so now we're going to do a cross product again, right? Notice one thing, guys. I have an M and an H and an M and an H. I want to be clear about this. What's the variable in the problem? What are we trying to solve for? We're really trying to solve for that M right there, correct? Okay, so really, I put H's on here. These H's and these other ones, these are just the units within the problem itself, right? Okay, good. So I have 1.5 M equals 2 times 78. What is that? It's 156. And so the number of miles that Phoenix will travel, what's 156 divided by 1.5? 104? Any issues with that? Cool. Jenna, guys, no shocker, right? If you work more, you get paid more. Now that doesn't necessarily work for some jobs, right? Like for me, I don't get paid by the hour, right? I get paid for the job, right? So some jobs are like that, some jobs aren't. So Jenna works her job and gets paid directly with the number of hours she works. She works 35 hours 1 week and makes that amount of money. How many hours will she have to work in order to earn that amount of money? So again, our comparison is hours. So what she gets paid, right? All right, so Jenna works 35 hours, gets paid $274.75. So how many hours does she have to work to get paid that? And again, we cross multiply. What do we get for 35 times 337.55? Nobody wants to share that with me? Really? Please? You guys are mean. I share, look at all the information I share with you, Cam. I share all this information with you. You can't share one multiple of numbers? Thank you, Aiden. 0.3. All right, divide that by this. Oops, that's 274. I flipped those around, sorry. 274. There we go. 43. Thank you, sir. Seem okay? Right? Very, very, very simple relationship, right? Hey guys, direct variation, one number directly influences the other, creates a linear function. Hey guys, what's a slope called? Y over x, change in the y over the change in the x. Do we all agree with that? Well, if change in y over change in x is the slope, isn't that a direct relationship of one number to the other? Yeah, right? So it's the same idea when we talk about linear functions. So two variables, x and y, vary directly. When x is 6, y is 4. The point is shown plotted below. There it is. Find the y values for each of the following x values. Okay, so guys, I have this relationship that exists, x to y, x to y, and that relationship is 6 to 4. So now it's saying, well, if 6 is to 4, then 3 is to what value of y? If 6 is to 4, then 3 is to what value of y? Guys, do we really need to cross multiply to do this? How did I get from 6 to 3? Divided by 2, so 4 goes to 2. Now if you cross multiply, you get 6y equals 12, and half of 12 is 2, right? So you're going to get there. All right, so we get y equals 2. All right, I'm going to plot that point. If I plotted that point would be 3 comma 2. 3 comma 2 puts me right here. All right, so now I do 6s to 4. Again, that's a relationship of x to y. So what is the value of -6? I'm sorry, what is the value of y when x equals -6? Guys, do I really need a calculator to do that one? What did I do to the value of 6 to get -6? Multiplied it by -1. So what's the value of y? -4. So now I have the value -6, -4, which is right here. Okay, guys, I can now play a game of connect the dots, can I? If I played a game of connect the dots, would these 3 lines be, would these 3 points be collinear? What does collinear mean? On the same line, absolutely. So I believe they would be. Let's check. Look at that. That's not exactly what I was hoping for. How do I? What do you guys think? How do you think we might change that? Oh, I saw it. Hang on. Pen properties. I want to go with a line. Pen. This one. What color do you guys want to make it? Yellow. Let's go. Ricardo. Got the dub. Oh, this is weak. Okay. Okay, so was my analysis right? Did they all wind up on the same line? Yes. Guys, really quickly, what is the slope of this line? Well, the slope of the line, how do I get from any point to any point? How many do I go up to get from that point to the other? I go up 2. How many do I go to the right? I go to the right 3. How do I find a slope? A slope is, I just said it, the change in y over the change in x, right? So how many y values did I change? 2. And how many x values did I change? So the slope of this would be 2/3. So what is the constant of variation? The constant of variation is 2/3. And that is the slope of this line. Guys, the constant of variation, man, I mean, it just sounds like, Cam, the constant of variation. What does variation mean? When I say variation, give me the first word that comes to mind when you hear variation. Change. So I want to go from this point, I want to change and go to another point. Well, the constant of variation tells me that when I change, I always have to change by the same amount. Well, this 2/3 tells me for every 2 y's, change by 3 x's, right? So these phrases sort of mean something when you really break them down. The constant of variation is the changing by the same amount every time. Write the equation that we plotted in A. Well, y equals mx plus b. I'm glad that we just reviewed this. We just said that the m value is the slope, which means that this must be the what? The y-intercept. So we found the slope. The slope was 2/3. Where does this graph cross the y-axis? At the origin, right? So what's my B value? It's 0. Now I'm going to put the 0 there just to emphasize, and then we'll write that as our final answer, right? Brian, is this reminding you of some things back in algebra class, right? Slope, y-intercept, change, right? Constant change, okay? Last little bit of the day is an application-based problem, right? So we have this girl, Abigail. And would you guys all agree that the number of gallons of gasoline in your vehicle will directly influence how far you can drive, right? So they give me the way they want me to set this one up, D to G. So that's going to be what? That's going to be the distance to the number of gallons. All right, so this says calculate the constant of variation. Guys, when they give me this piece of information, they're essentially just telling me what the constant of variation is, aren't they? So what is the number of miles that I can drive? 336 miles on 8 gallons, right? Does 8 go into 336 evenly? It does. How many times? How many? 42 times? Wow, nice car. Why did I say nice car? Because this car gets 42 miles per gallon. That's the constant of variation. Now, in this case, the slope, right, is something that we've heard of, right? Miles per gallon. So, yeah, I mean, there's an application. Give a linear equation that represents the relationship between D and G and express your answer as an equation solved for D. What? Give a linear, huh? Well, guys, I go to the gas station. I put some gas in the vehicle. If I put 1 gallon of gas in the vehicle, how far can I drive? 42 miles. If I put 2 gallons of gasoline in the vehicle, how far can I drive? 84. What am I doing? I'm taking the number of gallons and multiplying it by 42, right? So isn't it true then, guys, that the distance I can drive is equal to 42 times the number of gallons that I put in the car? Fair to say? How far can I drive on 6 gallons of gas? $42 times 6 is 252 miles. And what if I had a long road trip where I need to drive 483 miles? How do I figure that out? Well, the distance I have to drive is 42 times the number of gallons of gas that I have. I need to drive 483 miles, right? That's a distance. So 483 equals 42G. To solve for the number of gallons that I need, I just divide by 42. And so I need a total of 1. What is that now? Well, it's going to be, it's a decimal, right? What does it give me when I divide it? 12.11. What is it? 11.5 on the button. Oh, all right. On the nose, right on the right. It gives me. It says 11.5 in the calculator. Yeah. Oh, great. I'm glad we just saw that. Just really quickly, guys. And these are some of the little tricks that we gotta. Oh, by the way, This is why I want you guys each and every day to have a calculator at your desk. So you're going to want to grab one each day from now on and always put it back. This is why I don't want you guys using your phones to do these calculations, because things like that happen, right? And then all of a sudden you're sitting on an exam and you're not used to using the calculator and you don't know what to do. So I know that I have to what? I got to divide 483 by 42. 483 divided by 42. And it gives me this, right? So again, it's one of those things where we got to know how to use the tool, right? If this ever happens, the simplest way to fix it is to go highlight this answer, hit enter, and what does that do? It copies it, okay? Because here's the thing. If I want to fix this, if I go up here and I start typing on it, what happens? Nothing, right? So what I have to do to edit this, once I have an answer, once it's in this color, you can no longer edit it, right? Once it's grayed out, it's done. So if I want to fix this, I highlight it, I hit enter, it copies it, and all I have to do is put it, if I want a decimal, all I have to do is put a decimal any place. Now when I say any place, I don't want to put it in the middle of the numbers, right? What do I mean by any place? Either at the end here or at the end here. And when I do that, it'll automatically give me a decimal answer. That's another way to do it. Yep. There are really 3 different ways that you can do it. That's one of them. Okay. Another way that you can do it, and Skylar is right, is instead of just hitting enter, hit control enter. Or the third way to do it would be when you get this as a result, to go to the menu and to change the number to a decimal, right? So there are multiple ways to do it. You got to be able to do one of them, of course. Good? All right, so you have the assignment that follows this, and you guys got a few minutes to get started. Yes. Oh, yeah, sorry.